Alright, so now keeping with our systems, now we're going to be looking at solving systems of equations. We just did inequalities. Now we're going to do the same thing with the system of equations, still by using the graphing method. Alright, so for some vocab, systems of equations are when you have two linear equations in the same problem. Okay? And a system of linear equations may have either one, none, or infinite number of solutions. Okay? Just like regular equations, so you can have one answer. Now remember, if there's no answers, we call that empty set. And if there's infinite number of answers, we say that's all real numbers. Okay? Alright, now the intersecting lines. Two lines that cross at one point is called the point of intersection. Alright? So when you have intersecting lines, the point at which they cross is the point of intersection. The solution of the system, or the answer of the system, this is going to be the common point of all lines in the system. Alright, because there's two lines where they cross, that common point is the solution. Alright, and the independent systems, what that is a system of equations with a unique point of intersection. Okay? Alright, so our objective here is to solve the systems of linear equations by graphing. Okay? Now example 1, we want to solve the system by graphing. Here is our system. Our two equations are y plus 5 equals 2x plus 1 and y equals x minus 1. Okay? Now this equation, the bottom one, is ready to be graphed because it's in slope-intercept form. This one we're going to take some time and convert it to slope-intercept form in order for us to graph it. Okay? So, once again, we have y plus 5 equals 2x plus 1. Alright, so the first thing we have to do is distribute. So that'll be 2x plus 2 on that side. And then we're going to subtract 5 from both sides. Finally, y will equal 2x minus 3. Alright, so let's go ahead and just rewrite that over here. Y equals 2x minus 3. Okay? Alright, so now, just like we did with the inequalities, we're going to graph both lines. Okay, the only difference is, because it's an equation, the line itself is the answer. We're not going to do the shading. Okay? So the one we just did, the intercept is -3, the y-intercept. So go down to -3 on the y-axis. Put your intercept. Now our slope is 2. Remember 2 is 2 over 1. That means we're going to go up 2 and right 1. Okay? And now with the straight line, we're going to connect that. Alright, best we can there. Let me do that again. Okay. Alright. Now we're going to go ahead and graph the second equation in the system, which is y equals x minus 1. Y-intercept here is -1. And here our slope is 1. So we go up 1 over 1 every time. And you'll see that we landed on that same point right there. Okay? So now, when I connect this, here are our two equations. Our common point is right there. That is the one point that is on both lines. So the answer there, that point is at, start at the origin, we go 2 on the x, 1 on the y. So the answer is 2, 1. That's the answer for that system. Alright, now to check it. So once again, as always, to check it, we plug it in. Okay? So I'm going to plug in 2, 1 into both of these equations. Alright, the y is 1 equals 2x minus 3, where x is 2. So now it's going to say 1 equals 4 minus 3, and lastly 1 equals 1. That checks out, but it's got to check on both. So now we're going to do the second equation in the system. Plug in the y, which is 1, x is 2, minus 1, 1 equals 2 minus 1 is 1. So it does check out. That point satisfies both equations at the same time, just like it does on the graph. Okay? Alright, let's take a look at another example. Example 2. We're still going to solve the system by graphing. Now we have, remember this is one of our unusual graphs, x equals 5, and there's only one variable. Remember that's a weird one. And hopefully remember x is in the vux. So this is going to be a vertical line at x equals 5. So on your x-axis go 1, 2, 3, 4, 5. And we're going to make our vertical line here. Alright, so that's one of our lines in our system. Now the second line is not in slope-intercept. We need to take that x minus y equals 7 and change it. So we're going to do minus x on both sides. We now have negative y equals 7 minus x. And to get rid of the negative in front of the negative y, we're going to divide by negative 1 and divide every term by negative 1. Y is now by itself. 7 divided by negative 1 is negative 7. Negative x divided by negative 1 is positive x. Rearrange your terms so that your x is in the front. It's a positive. The 7 is negative. Alright, so this is our actual equation for the system, now that it's in slope-intercept. So let's graph this. The intercept is at negative 7. So 1, 2, negative 3, negative 4, negative 5, negative 6, negative 7. And our slope is 1, so we're going to go up 1 over 1. Every time you'll see that it's going to cross right there. Alright, so now the point that is in common for both is this point right there. Alright, so that point is at 1, 2, 3, 4, 5, and then we go down negative 2. 5, negative 2. Now once again, let's check it by plugging it in. Now this first equation, x equals 5. Now, we only have x. If I plug in my x value, 5 equals 5, that checks. There is no y to plug in, right? That one was kind of weird. Now this one we're going to plug in for this equation. Now the y is negative 2 equals the x is 5 minus 7. So this is negative 2 equals 5 minus 7 is negative 2. It checks out. So that point is the answer to that system of both equations. Okay. Alright. Now, we're going to look at some of the ones that are kind of unusual examples and go back to some vocabulary again. Okay. Now remember, so the two examples we just did had one answer, 1 point. Now we're going to look at the ones that we said could have no answers or infinite answers. Okay. So, once again, we don't say no answers, technically call that empty set. And the empty set is the answer when the lines are parallel. And the thing to remember from a couple chapters ago is that when lines are parallel, we know that because they have the same slope. Okay? And then next, this blank is going to say all real numbers. I'll just reread that. All real numbers. So that's the answer when the two equations or lines are actually the same. Right? It's the same equation, which makes it the same line. And because it's the same line, they're basically on top of each other. And that means the lines intersect at every point. That's why it's infinite solutions. Okay? Alright, so let's take a look at these in practice now. Alright, so example 3, we're going to solve this following system. First equation is already in slope-intercept. Second equation we need to convert to slope-intercept. So we're going to solve for y by first doing minus 2x. So now we've got 2y equals 8 minus 2x. And then to get y by itself, we're going to divide everything by 2. Now we are down to y equals 8 divided by 2 is 4. Negative 2 divided by 2 is negative x. Now we just need to rearrange our terms. Remember that's a negative x, so keep it a negative x just because we moved to the front. This 4 is positive, so when we move it, keep it positive. So negative x plus 4. clean that up a little bit there. Alright, so now we're going to use this for the other equation in the system. Okay, so let's take a let's graph these and see what we got here. First equation, y equals negative x plus 1. The y-intercept is positive 1. Now remember, now my slope is negative 1, which means negative 1 over 1, which means we'll go down 1, right 1. Down 1, right 1. Down 1, right 1 every time. Okay? So we're going to go ahead and connect that graph here. Or those dots, I should say. So there's that line. Now when we graph this one, which is y equals negative x plus 4, now the intercept is positive 4 on the y-axis. 1, 2, 3, 4. But the slope is still negative 1. We're still going to be going down 1, right 1 every time. Okay? So now, when you look at these two lines, because remember, our answer is, because this equation, here's the answer every point. This equation, every answer is a point of this line. But because it's a system, the answer is where they both have the same point. These lines never touch. There is no point of intersection. That means there is no answer. Alright, so in this case, our answer is empty set. Okay? And once again, hopefully we start recognizing this. We know that these lines are going to be parallel because their slopes are the same. Both slopes, or both lines, excuse me, have a slope of negative 1. Okay? And for the check, I mean, because there's no answer that'll plug in, nothing we plug in will check it. Okay? So, just to check it and be sure though, I mean, if nothing works, I should be able to take anything. I mean, I'll just take a point on one of these lines. Like, the easiest point would be 0, 0. Right? So if we check that, if we plug in 0, for the first one, y equals negative x plus 1. 0 equals 1, that does not check out. And then if I come down here, y equals negative x plus 4. 0 equals 4 doesn't check out. Nothing will balance these equations out. So that's why it's empty set here. Okay? Alright, now let's take a look at this one. So now we have this system of equations. Neither of these are in slope-intercept form, so we're going to need to change both of these. Okay? Alright, so let's take this first one. I'll just come down here for now. We'll erase this. Okay, x plus 4y equals negative 4. That's messy. Okay, so we're solving for y, so to get rid of the x first, we do minus x. 4y equals negative 4 minus x. And lastly, we divide everything by 4. So y is going to equal negative 4 divided by 4 is negative 1. And then remember, this negative x is negative 1x. So that's going to be negative 1/4 x. And then we just rearrange it. Bring your mx up front. Negative 1/4 x minus 1. Alright, so I'm going to write that on top of here. So this is it in slope-intercept. Negative 1/4 x minus 1. Okay? Now we're going to need to turn this second equation into slope-intercept. So here the equation is 1/4 x plus y equals negative 1. So to get rid of the x, to get rid of 1/4 x, we're going to do minus 1/4 x. Y is by itself. Now we have negative 1 minus 1/4 x. Put your mx in front. Negative 1/4 x minus 1. So let's put that under here. Alright, it's a little messy. And y equals negative 1/4 x minus 1. Alright, so now let's graph these equations. Alright, so the first one was negative 1/4 x minus 1. Y-intercept is negative 1. Now the slope is negative 1/4. So we're going to go down 1, right 4. Down 1, 1, 2, 3, 4, right 4. Down 1, 1, 2, right 4. Alright, and there is our line for the first equation. Now look at the second line. The second line is negative 1/4 x minus 1. It's the same exact line. So you see both of these lines are the same line. That means they don't touch at one point, they touch at every point. Okay? So that means the final answer here is all real numbers. Okay? And it's probably better to write that in set builder notation here. X such that x equals all real numbers. Okay? Every point is an answer. Okay? And if I just take any point on this line, well, let's go ahead and take the intercept. That's an easy point. This point is 0, negative 1. So let's plug that into both of them. Alright? So negative 1 is the y, equals 1/4 x, x is 0, minus 1. So negative 1 equals negative 1/4 times 0 is 0. Negative 1 equals negative 1. And it checks out. And because it's the same equation, it'd be the exact same thing. I don't have to do it twice. But I could plug in any point in this line, and it would check out. Answer is all real numbers.